And welcome back. Now today I'm going to be looking at two boards, one from Elecrow, this one here, which is not just a screen as you might think there, it is in fact a fully fledged board, yeah, with an ESP32. Talking of ESP32s, if you remember in my last video I mentioned I designed a very simple ESP32 sort of dev board, sensor board, call it what you like, and yeah, we'll have a quick chat about that as well. The two just happened to coincide. Elecrow asked me to have a look at this and to tell you guys about it, so they've supplied this for me. This was my own work, and the board was done by PCBWay, but I paid for the board myself. Yeah, I know, unusual, isn't it? Just to get things moving along. So let's have a look at both those and see what we can find. I want to give a big shout out to PCBWay, PCB prototype the easy way. Now, we're all well aware of the $5 for 10 pieces PCB, but I've got some real practical examples that I've ordered recently. Let's have a look at those. So here we have a very small double-sided panelized board that enables me to create a tiny little display unit. Look at that, how cool is that? And at the other end, look at this pond controller. Mains voltage, absolutely wonderful. That looks pretty cool too, doesn't it? And that's been running for some time now. Yeah, PCBWay has excellence in their PCB department, but that's not all they do. Look at this. Just look at their products and capabilities. Apart from printed circuit boards of all types, they do PCB assembly, double-sided, through-hole, surface mount, you name it, which means you can design a prototype for yourself or your company and have it assembled by PCBWay for the cost of the shipping. And if you want some 3D printing done, these are the people to do it for you as well. PCBWay. Why don't you try them out now? Okay, first things first then, let's have a look at this board here. As I say, Elecrow sent me this board because they said we've seen previous videos where you've used these sort of screens and sounds like a good fit for your channel. And yes, I agree. In fact, if you remember my web radio that's actually up there on the shelf and it's playing at this very minute, although I've turned down the volume, of course, we don't want any copyright infringements here. It's still working and running fine. This particular board actually has a slightly different variant of the screen that I used. It's still an ILI, but it's basically a 3.5 inch HMI display, 320 by 480, so it's not bad, and you can get these in all sorts of different sizes from Elecrow. Not necessarily with this on the back. You can, of course, just get the screens themselves. So I'm going to plug that in, and because they've got a demo program on it, well, I wanted to show you first before I zap it with one of my own. So let's do that and see what happens. There we are, it's running. I guess this is Elecrow's own little demo program, just to show you what it can do. Oh, there you are, look, I've suddenly changed my name. Now, this does come with one of those little stencil things, styluses I should say, which I do have somewhere, so let me find that. Well, I can't find it, so we're going to use my Chinese chopstick thing instead. Now this is just a demo program to show you sort of the abilities of what this screen can do, I suppose, really, although in some ways it's more what the app is doing, isn't it? So it's trying to emulate at the moment a web page, which I've got to be honest, doesn't work that well because it's slow and refreshing. As you can see here, it sort of ripples up. I mean, this isn't a Raspberry Pi with a proper, screen on it, but I guess it works well enough. I think it works better, this sort of screen, as per my web radio. So just to explain what I mean about paging and stop making things look like a Raspberry Pi when they're not really capable of doing it. This is my web radio in the 3D case that I didn't design nor print, but some kind user sent it to me. So this is, if we go to the channel list, for example, on here, and I'm on page 5, I can tap this one here, look, and it just goes back real quick, and it's building these up from all the list of URLs I have. And I think it works a lot better that way than trying to sort of scroll a big list up as though it were a paging or scrolling web page. That's all I'm saying, really. If you want a Raspberry Pi, use a Raspberry Pi and a proper web page. If you want an ESP32, well, do it this way. Just a suggestion, really, that's all. Is when it just flips to another page. So if I click on the analytics here, for example, They are, that's whizzed across, and the shop. Yeah, I mean it's probably a better use of it rather than this scrolling, although it's a bit like a talking dog, isn't it? It's not that the dog talks badly, that he talks at all is the amazing thing, and the fact we can actually scroll this up and down at all is a testament to the library they're using, which is the LVGL. It's an open source library. It's a light and versatile graphics library. We'll talk about that in just a minute. Okay, let's just have a quick look at this board then. Not necessarily the screen itself. I mean, that's a standard sort of LCD TFT screen, isn't it? Quite nice. As I say, I've used one in my Web Radio one for 2-3 years now, and it's worked fine. Let's look at the back though. Now on the back here, I'll try and put it around the right way actually. There we are. So that's what you have on the back. So you've got an ESP32 module here. This is a W-Room one, not the Rovo. Slightly disappointing for me that you can't have the Rover version, because the Rover has extra PS RAM, which is what I use in my Web Radio. It's just basically more storage for things like, you know, circular buffers, which is what I use it for, or potentially web pages. You can load them up off the SD card, which this also has, of course. Load them up from here into extra memory, and it's much quicker than trying to read it off the SD card. However, that said, it's still, you know, an S2 processor here, dual core and all the rest of it. Nothing different about that. And this also exposes various bits of the infrastructure, if you like. So you've got UART, I2C, GPIO, D it says there. So that's, well, various I/O pins you can see there. This has got a USB-C interface here for standard debugging, if you like, or serial output plus power. Although you can also plug in a battery here. And I'm assuming, I haven't actually tested that bit out of it, that the battery is automatically charged up by this. I've got to assume that. But there's so much documentation. I'm not kidding. If nothing else, Elecrow ought to be applauded for the amount of information they have on, well, not just this board, their entire gamut of offerings. It's huge. And if you're interested in doing anything, either just with the screens themselves or with this board in particular, you really got to read their documentation. It's just huge and comprehensive and marvellous. Okay, there's also a socket here for speaker, which I did in fact query with them, because I'm sort of halfway through playing about with I2S on a different project. If you remember, well, no, let's not talk about that now. But anyway, I was on a project with I2S, and I said, hang on, how can this run directly from here without any kind of intervening chip? And they said, well, it uses the inbuilt facility of the chip. So you're talking 8-bit sound, which is, yeah, okay. Maybe we'll look at this aspect in a future video when I do the I2S version for myself. It's a bit slow going at the moment, other things on. By the way, yeah, if you're thinking, what is that noise, Ralph? What are you doing? Unfortunately, I've got my 3D printer running. There's no getting around it because it's a long print, you know, a couple of hours. I've got to get the thing running. So if you do hear sort of whining motor types noises, it's because that's running. So let's just ignore that. I'll talk more about 3D printing in this video if we got time. But let's carry on with this. Anyway, so we got all these various sockets that do various bits and pieces. Yeah, boot reset and all that. Fine. And we have the demo program on here. Now it's upside down, of course. But let's just put one of their test programs or their example programs on here using the Arduino IDE just to prove it works. And if one works, they all work. And we'll be using the LVGL open source library. Yeah, which is probably the most well thought of library, although it's different to the one that I used on my Web Radio, which I'll also mention. Right, so this is the code. It's all pretty small, and as I say, it's all written by Elecrow, I guess. There's only a few lines setting up the pin modes and whatever, and then filling up something on the screen. So the only reason I'm doing this is to make sure it does upload to that board properly and runs. So let's do it. This is a one-way operation, as much that the demo program now on that Screen ESP32 combo is now going to be zapped, which is why I haven't done it ahead of time, because I couldn't show you that initial demo. Right, okay, let's upload this then. I'm on COM3 it says, so well, let's have a look. Okay, I've uploaded a sketch, and hands up, okay, it's not the same sketch as what was on the screen a minute ago, because that sketch used the LVGL library, this lightweight library that Elecrow are sort of promoting, I suppose, really. But the examples they gave, I don't think they were for ESP32s. There was something else. Maybe it's a Raspberry Pi or something, but whatever. It wouldn't even compile. So I found some of the sketches that do compile. And okay, I'm going to load one up now. Now this uses the same graphics library. I think it uses the underlying Adafruit graphics library, but the one that I'm actually using is called TFT _ESPI from Bodmer. Very well known, and so I've used it for my web radio and it works great. So let me just switch this on. Right, there we go, switch it on. There we are, so you can see it's nice and colourful. But anyway, you can see it, right? You can see that it's working, and every now and again, there, look, it refreshes. So at least it all proves that it's all running from this one device. I must admit, I haven't actually looked to see whether or not there are enough pins on here. Hello, who's ringing me now? So, as I was saying, before I was so rudely interrupted, I haven't checked to see whether there are enough pins exposed here via these various sockets for me to run my MP3 decoder little module on here and therefore turn this into a web radio. Because it's, you know, very compact, isn't it? It's quite nice. It'd be the ideal thing to do. What I also didn't mention is that, oh yes, I found the stylus that comes with it. That's this thing here, right? So, you run a sketch on here just to calibrate the coordinates, left, right, up and down, in the middle and all that, and that all works as per. It's nothing different to what I'd done before with the web radio, and it works very well. They also give you this connector, which they call some kind of crow connector. I don't know what the real, or perhaps that is the real name, I don't know. It's a bit like a KF2510, but I don't know. It's latching, and they just latch into there. The two that aren't of that type are the speaker, that one there, and that one there, the power, which is standard sort of 2-pin, what do you call these? The ones they use on drones. Can't remember the name. I'll put it on screen. Yeah, just beware though with this sort of pin that the positive and negative are not always the way you think they should be. And in fact, if you look at that screen there, you can see the positive is expected to be at the top of that socket. Yeah, and yet look at this pin. Look at this pre-wired. This is a pre-wired header. And you can see that the positive is in fact at the bottom. That's how I blew up one of my ESP32s quite a while ago, because I just connected up the battery like this and kaboom, that was the end of that. Because it's wired backwards basically, so you have to literally get a very, very, very thin and delicate screwdriver and poke it into here and pull those wires out and change them around, and then it all works. Might not happen to the ones you buy or make, so yeah, it's not always going to be the case. Right, that's that. Now you'll see this just running in the background while I play about, because I want to upload another sketch to this now, just to test out the speaker, well, the speaker socket, and I've got this speaker that just happens to have that plug on here. Oh, there we are. So I've just happened to have one of these for a future project. Yes, right, my door. Yes, do you remember that? My door announcement, chimes and all that. So yeah, let's see if this actually works. Okay, right, now nothing to do with the screen this time, but I thought I'd load up a program that does the 8-bit DAC. You will be able to hear it from here. Can it count up to 10? Now I've got to get the actual program running on the Arduino and type in some numbers. So if I type in the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, which I've just done, and hit enter.
1, 2, 3, 4, 5, 6, 7, 8, 9, 0.
Okay, so it actually worked. A little bit, yeah, the quality cannot be considered to be Wi-Fi by any chance. No, it's 8-bit, let's face it, yeah, and I'm going to do a future video with some slightly better quality audio, I hope. But until that time, at least it shows that just from a single speaker plugged into one of the DAC pins, in this case it's 25, I believe, pin 25, or 26. You can use 26 as well. That's what the sketch uses on this one. This is called ESP32 Elecrow Speak Numbers.ino. So there we are. That's one of their examples. Pity there was a little bit of a coding error in it. It picked the wrong DAC pin. But if you just check the code against the schematic that they also provide, then it's pretty obvious what's going on. As a unit, a screen, a 3.5-inch screen, ILI9488 type, plus all this bit on the back. We haven't even looked at the SD card, which is always useful to have. I know these days we've got spiffs, or rather we've got little FS now, built in, hardwired into the framework of the ESP32. There's no need to add anything, it just works out of the box now. So you can forget that video I did a long time ago now. Well, I had to get it working for my web radio to actually set up a new partition and all that, but you don't have to do any of that. It just works out of the box. So you can have various partitions in the memory on here, as though it were another SD card, really. Okay, that's that. Let's just have a quick look at the website then to see where all this comes from. So this is their web page, Elecrow's web page, and as you can see there, it's currently $18.83. Hello. Oh, there's a little magnifying glass. Not on the price though. So it's gone down from $26.90 to $18.83. I don't know whether that includes taxes or duty or anything else. Everything I buy from China these days incurs VAT that's collected on behalf of the UK government. We think. So it puts the price up by 27. This is a real bummer. I mean, it's stopped me buying so much. But anyway, you can also have it with an acrylic case for an extra $1.80. And in some ways, I haven't got one, but I wish I had now. Because if I scroll down, now look, there's the case, look, that goes on it. Another sort of protects the screen, lets you hold the thing properly while you're using it, which is a bit of a pain otherwise. So yeah, spend the extra $1.80 and there we are. Spend the extra $1, so it comes to $20.63 now, and I think it looks quite nice. Lots of pictures on here. Now, if I scroll further down on this page, you'll see that there's a whole wealth of information, a couple of videos, and this and that and the other. And right down the bottom, this here it talks about LVGL and all the rest of it, and the fact you can code in MicroPython if you want to. No, I don't want to. There's various instructions. I think we've been through these. This is all to do with LVGL, which I could never get to work. So that might need a little bit of polishing from Elecrow to get that working for Arduinoites who are just starting out. But there's a good few pictures here. Look on, what all the things on the back of the board are doing. What else does it show? Yeah, the comparison between the various screens. So my one's bang in the middle there, 3.5 inches, which is, a good size. Yeah, we'd all like to run a 7-inch, but it's pretty huge, isn't it? I mean, you've got to fit it in somewhere. Anyway, so mine's the 3.5 inch, works fine. Just be careful of the drivers. Look, they do change between sizes. You've got a 9341 there, 9488, NV3047. Never heard of that one. But anyway, all various different ones, right? So there's a good comparison there about what it does. And if we go even further down the page, these are all the links to, there's the schematic that I should have looked at really first. It's in, it's an Eagle format, but I imported it into my CAD program, no problem at all. Data sheets, programs, the whole, if you're interested in this, if you think, yeah, I want one of these screens, with or without the ESP32, but especially with the ESP32, then this is your source of knowledge. Just be prepared to, how can I put this? Be prepared to put some time in to look at all the options, because if you just take the sample programs, like I just took that one for counting, for example, they got the DAC pin wrong. The comment says, we'll use one of the DAC pins, we'll use DAC pin 25, and it was silence. And I thought, really? Are you really using DAC pin 25? I had a look at the schematic, and it says, no, I'm using DAC pin 26. Let me show you the schematic, just so you know I'm not making this up. So this is the schematic diagram of the entire thing, and as you can see, it's far too small. But of course, you can zoom right in as big as you want. All CAD programs let you do that. But down here in the left, there's the speak bit. This is all to do with the DAC then. So if I zoom in on that, there's the speaker symbol over on the right, or the socket, I should say. And if we scroll right, it says IO26 speak, not IO25 like it says in the program. So yeah, just be prepared to work around a few things, and it all just works as you heard. Works great. But the documentation is rough around the edges. So Elecrow, if there's one thing I've got to say, that needs to be improved for beginners. It needs to just work out of the box, right? Okay, I think that's enough about this particular product. That I say, Elecrow did say, look, are you interested in showing your viewers? Just take this one and do what you will with it, which I've done. And I certainly hope to progress this and see if I can put my MP3 decoder module, plug it in somewhere, just to get it working properly for a web radio. I don't know if that's possible. And with the amount of other work I've got on at the moment, it'll probably be Christmas time before I get around it. And I'm not saying which year. But I think this is a nice board. It all seems to be very solidly built, and as I say, there's it's good for beginners. All these sockets and stuff. I think that's nice, and it's got just about every single function you want there. A couple of things about the board I don't like. One is you do have to press reset and the boot, and then let go of the reset every time you upload a program, and then this is certainly from Visual Studio Code, Platform IO. When the code is uploaded and it says I'm now doing a hard reset, which would then start the program normally, it doesn't. You have to actually press the reset button again. So that isn't working. I don't know why. Bit annoying. So, I mean, all my boards, I just put a small capacitor on the reset button and it works. But on here, I wondered if their one was a bit dodgy, so I took it off. It's that one down there, just above my thumb. I took it off and put a different one on there. Made absolutely no difference whatsoever. So I don't know what's going on there. Now the other thing is, although they do supply that little case, which is great, anything you plug into these sockets, of course, will stick out at the edge of the case. I'm thinking these sockets maybe should have been put in much further inside, well away from the edge, so you could plug something in and have the cable coming out, so that the case could be the same size then as this board, really tight. Now, of course, I know. Now I've got a 3D printer. I can make a case that fitted this screen exactly, to within the millimetre. And the last thing I'd want is then to have these sockets on the edge for cables to be scrunched into, because they wouldn't fit, basically. That sample one, for example, imagine that plugged into there. Well, let's do it and have a look. So that's plugged into there like that now. You can see how much extra room that takes. So I'm just saying, for compactness, I think it would have been a better design to have these sockets further in on the board. But I'm just saying, if you were making a board, you might want to do that. Having said that, the board I made for my demo, which I'm not going to have time to talk about now, I put all these sockets on, but they're vertical, you see, so that if there was a screen this side, at least they wouldn't impact on the overall size of the board. But there we are. That's just personal preference, I think, really. Loads of documentation, as I say, and I think the price is probably quite good, even allowing for that horrible tax that the Chinese companies seem to levy now on all UK citizens. I've no idea what they do to the States people. I mean, they have sales tax in most states. Do you not in the States? So do they add the sales tax on, or perhaps you just don't get charged tax from stuff from China, which would be great. That's how it used to be in the UK until I think it was 2021 or 2022, and then they put it back on. So there we are. Okay, that'll do us for now. Now, if you've got any questions about this, I'm obviously going to put loads of information in the video description below and in my GitHub, like, for example, which pins are being used to drive that screen. I had to go back to Elecrow and say, I can't get this to work, which pins are you using? And then they showed me a snapshot of the schematic, at which point I went, oh, duh, I should have looked at the schematic myself, which I did and followed it up, and it's all fine. But I'm going to put all that information down there so that hopefully you'll be able to go to my GitHub. So let's assume you've bought one of these, right? You go to my GitHub, download one of the zip files and go, right, just run, and it will just work out the box, you know, like that speech one corrected now. There was a couple of issues with the code, deleting an object without a virtual destructor, for example. I mean, it sounds complicated, but you can't do that sort of thing. Well, at least the Visual Studio Code will not allow you to do that sort of thing. It gives you a warning which it treats as an error, but even if you ignored it, chances are your code's going to blow up. So there's a few little things there. I've corrected all those, and I'll put, I don't know, 2, maybe 3 examples there, and then you can play with it and try them out. But yeah, I like it. I like it overall. Probably aimed at the sort of middle tier enthusiast rather than the absolute beginner as it stands. But I think Elecrow could make this for the absolute beginner if they got that documentation and hand-holding correct right from the start. That's just my personal opinion. Okay, we're all done and dusted. Now remember, if you want to say something to me, put it in the comments below, yeah, because I do reply to your comments. I'll read them all. If you like this video, you think, yeah, that was okay, I enjoyed that, give it a thumbs up, yeah, because I want to hear the
hey.
Yep, the yay, yeah. And if you like these sort of general videos, which I know are getting fewer and fewer these days because I'm overwhelmed with other work, you got to subscribe. And John at the back, what else you got to do? Correct, you've got to ring that bell, because if you don't ring the bell, you don't hear when other videos are released. I know it's crazy, isn't it? Crazy, but there we are. That's the way it is. Okay, and I'll see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.